This is the question that I sent on for you to do yesterday from the Junior Cert. Each of the 4 diagrams, A, B, C and D, shows an object, figure 1, and its image under a transformation. So we've done something to the image, whether, I don't know if you remember in primary school where you would paint half a butterfly and then you'd smash it over. So that's a type of transformation here. So for each of them, we have one transformation, either a translation, that's where you literally just pick it up and move it. You don't change anything. You just literally pick it up and move it to a different spot. Axial symmetry is where we have some sort of axis. So if I fold this paper in half, there's your axis of symmetry down the middle of it. And maybe if I, let's see if this works. So if I put enough ink just there and I smash it over, and just see if I can rub it in. You can kind of very vaguely see the image of it. So this is maybe axial symmetry in your, if we wanted in your y-axis, if we were calling them by the x and the y-axis, or central symmetry. Central symmetry is where you go through a point and out the other side. Okay, so here's your figure. If we look at this one looks like axial symmetry and the axis is here. So I'm looking at B. If you fold the F down along where the pen is, that's your axis of symmetry. And then, so it would look like this. You paint this and then you smash it down and it would look like this. So that one looks like, B looks like axial symmetry. C looks like a translation. Picked it up, just moved it. So if we look at this point here, the bottom of the F goes through that point and out the exact same distance on the other side. Same with this. So if we looked at, this part of the F, it goes down through this point here where my pen is and out the exact same distance on the other side. This one goes through it and out the exact same distance on the other side. This one looks like central symmetry through this point here. And let's see, maybe if we did this axial symmetry, and it's not through a vertical line or a horizontal line, it's actually through a diagonal line. You can see that the way I'm seeing it. So that was yesterday's question, your Junior Cert question. And now I want to get the other one. No. Hold on it. So let's go back here. So we had this one. This was the other question, just that you had to do yesterday. And you just had to fill in these points. So -5, 0 is B, A is 0, 5, and C is, B is -4, 0, and C is 4, 0. So that's the first part done, part 1. I had to give you those coordinates. And part 2, it says find the total length of the metal bar. So here's one metal bar and here's the other metal bar that is needed to make this part of the swing. Give your answer correct to one decimal place. So I'll worry about that at the end. So I need the length of this bar. You can work it out loads of different ways. Probably the most straightforward way. I'm going to go to my log tables. I'm going to go to my coordinate geometry section. And I'm going to use this formula here because it gives me the length between 2 points. What are the 2 points that I want? Well, I'm going to have a look at on the diagram there, point B and point A. B we said was -4, 0, and A we said was 0, 5. If you look at your log tables, it says how to label them. Call one of them x1, y1, the other one x2, y2. So I'll just call this x1, y1, and this one x2, y2. And then I get my formula and I carefully fill it in. So I want x2 minus x1 to be squared plus y2 minus y1 to be squared. And that gives me the length of this line here between this point and this point. Carefully fill it in. Square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Throw that into the calculator and you end up with the square root of that's root 41. So that's from A to B. The other bit of metal that I need goes from A to C. You can see this on the diagram. Get the length of that line using the same formula. It actually ends up being the same, which you might have been able to see from the diagram. But, you know, just check it out just in case. So you've A to B is root 41, and A to C is also root 41. So that's 2 times root 40. 2 times root 41, and that gives me 12.8 when I round it off to 1 decimal place units in length.